This is the 12th program in the series on mathematics for electronics. It's about solving linear equations. In earlier programs, you solved problems by using formulas that contained letters. The formulas showed how the quantities represented by the letters were related. You could replace all of the letters with values except for one, say x or y or whatever. This was your unknown, which you were solving for. Even though you'll always solve for one unknown at a time, it's not always best or easiest to set up just one equation with one unknown. For example, suppose you know that the total resistance of two resistors, call them resistor X and resistor Y, is 24 ohms. The first equation or relationship you make is that R sub X plus R sub Y equals 24 ohms, but you still know nothing about their individual values. But if we'd also said that R sub X is equal to 5 times R sub Y, the solution comes quickly. What does R sub X equal? Correct, and R sub Y equals 4 ohms. We have solved a problem involving two unknowns and two equations. We solved it by a method called substitution. We took the value for one unknown as it was given in one equation and substituted it in place of the same unknown in the other equation. Our two equations or relationships were that R sub X plus R sub Y equals 24 ohms and that R sub X equals 5 R sub Y. By substituting 5 R sub Y in the first equation for R sub X, we got 5 R sub Y plus R sub Y equals 24 ohms, or R sub Y equals 4 ohms, and R sub X equals 20 ohms. This process allowed us to simplify the problem into one having just one unknown quantity. What do we call this process? Yes, besides substitution, we can solve a problem with two unknowns and two equations by using graphical methods and by using the algebraic difference between the two equations to eliminate one unknown. This last procedure is called solving simultaneous equations. Let's consider how we can use graphical methods. Here's a graph of x equals 2y. By looking at it, we can predict what the value of y will be for any value of x. When x equals 0, what will be the value of y? Correct, because even if x is always twice as large as y, as the equation shows, when x is 0, y is also 0. A graph is composed of the intersection of a horizontal line and a vertical line. We call these lines the x and y axes, respectively. Their intersection is called the origin and is 0 in value for both. The x-axis is positive to the right of the origin and negative to the left, while above 0 on the y-axis is positive and below 0 is negative. If x is increased, which way will it move on the axis? Yes, and as the value of y increases, it will move upward. Because x and y are letters which stand for values which can vary, they're called variables. Letters or numbers, on the other hand, which represent known values, are called constants. In the graph for the equation x equals 2y, we said that we could predict the value of y whenever we change the value of x. The value of y is dependent then on the value of x. A variable whose quantity varies according to the value of another variable is called a dependent variable. What do you think we would call x, the variable whose value in this case determines what y is? Right. We usually choose to call the independent variable x, and its value on a graph will change horizontally. The dependent variable, usually called y, will then vary graphically up and down. Consequently, we generally think in terms of how much vertical change occurs with a change in the horizontal value. Another term is function. We say that the dependent variable is a function of the independent variable. Let's say you use a gallon of gas for each 20 miles you drive. Show this that 1 mile equals 20 times 1 gallon equals 1/20 miles. What variable would be considered a function of time or miles driven? Yes, a graph of our example of the resistors would be a graph of the equation R sub X plus R sub Y equals 24. If resistor X has a higher resistance, then resistor Y obviously